Hi, good morning, everyone. Wanted to do this video on the topic of using lookup tables in Excel in conjunction with a match function. So a match function is something that Excel has available, but it is not something you can simply do in Cameo. There are some interesting workaround solutions, however, and that's what I'll be showing you today. So what a match function does in Excel is it essentially looks at a range of data and it finds a value that you give it as an input, and then it finds a position in an array that's closest to that, whether that's greater than, less than, or equal to that value. In the case of this lookup table, if I give it an input value of 0.3 that would be looking at this range of data, if I give it the less than function in conjunction with that match function, what it would do is it finds where that would fall within this array, and then it finds the value that is next to that, but just less than that. So in this case, if I give it a 0.3, it's going to find this value of 0.25. And what we can do with that is use that to find rows and columns that we want to actually look up in this Excel lookup table. In this case, I had this table, and what we can do is actually attach that to your model. I have this example spreadsheet 1 that is an attached file. So anytime you want to attach a file to your model, you can go to create element and then attach the file. There are other ways you can sync data with tables as well. In this case, it seemed to work out very nicely to simply attach the spreadsheet to the model. But then instead of actually referencing those cells and trying to instantiate those directly in a simulation, I took the approach of recreating the values that were in those axes. So on the x-axis and on the y-axis. So if we look back at this spreadsheet again, I actually grabbed all of these values and gave them to ChatGPT and said, I would like you to create a comma separated value array of this data. And it gave me those back, and I simply put that in as value properties. So if we look back at the model, notice we have these two arrays that we've named x-axis and y-axis. So one thing important about arrays is that you want to set the multiplicity to allow an unlimited amount of data. You could set that to the exact number of the positions in the array, but in this case, I simply gave that an asterisk, which means 0 to unlimited. What's also very important is that you change this to ordered and non-unique. So by default, value properties are not ordered and they are is unique true. And what would happen is if we were to leave that, when you were to run a simulation of this, Cameo a lot of times would change the ordering around of the values in the array, and it will also drop the duplicate values in the array. So notice how I have a value of 0 and a 0 there. One of those would be dropped off. So it's very important that you change this to is ordered and non-unique. That way it keeps all of those duplicate values and keeps the strict ordering as well. Now that we have the array, notice this is in brackets. One other thing to mention about arrays, if you have trouble instantiating those, is that it's good to go into the value properties default value and make sure it's an opaque expression. So there's a few options that you have here, but by default, that is not an opaque expression. So if you have troubles where you're not seeing some of the values showing up and it's not instantiating as an array, you'd want to go in and make sure that you actually change that to where it is an opaque expression and then it's in brackets as well. And then when you run that simulation, you'll see that there will be an array of data there. I have this x-axis, I have this y-axis. So now what I'd like to do is use this match function, but as I mentioned, match functions are not something that Cameo has built in, but with a little help of ChatGPT, again, I was able to get two different options here. One of those being a Groovy script, and then another one that works just as well is in Python. If we look at the parameters for this, we will give it the list, and then we will give it a lookup value. That's one of the inputs we're giving it. And then we would like it to output the position of that. So then we're going to do that twice. One of those will give us the row coordinate and the other one will give us the column coordinate. And then we can use the row and column to do an Excel lookup. And all we have to give it is the file name, the sheet name, the row, and the column. Now, if you notice in this Excel spreadsheet, we have these axes that are not starting at cell A1. So what I did is put in an offset, because when you look up a column or a row in Excel, it's actually going to go off of the A1 being the base for that. So if I were to want to return this value here in my array, that's position 3. but in the Excel spreadsheet, that's actually column 5. So I added a little bit of an offset in there, and that ended up working out nicely. When we look at parametric, what you'll see is all of these will be bumped over 2. That will give us the correct data. If we look in the parametric for how this is connected, I'll go ahead and run the simulation. And what you'll see is we have the array for the x-axis here, we have the array for the y-axis here, and then I'm giving it some random values to look up. So for the x-axis, I said, let's look up the value of 0.3, and in the other array, which is simply this array here, it's not looking this up in the table, it's simply looking this up in the array and returning the position that is less than that in the array. I said, let's look up this value of 1.3. So if we look at the spreadsheet, that would actually give us this value here because 0.3 is just between these, and I wanted the one that's less than that, so that puts us there. And then for the y-axis, I gave it the 1.3, which would happen to fall on the 1.25 cell. So that gives us the output data that we're looking for is the 2.45. So if we look, the final result that we have here is a 2.449, which rounds up to 2.45. That's how we were able to do a match function and use that in conjunction with the Excel lookup. Something to mention is Salius Pavalkis also has a video about this on his MBSE execution channel that is good. If you were to look that up, he uses some of these in opaque behaviors, so you can use these in opaque behaviors as well. But I thought it was neat to do this strictly as a parametric. That way, if any of these values change, you don't have to rerun a behavior. They simply recalculate, they relook up all of that data for you. So let's say we were to simply change one of these values to something else. Notice it does the adjustment there and grabs that new data point for you out of the Excel spreadsheet. So I hope you found this useful. If you have any questions about this, please feel free to reach out. Thanks.